Many believe that the Andromeda Galaxy is a twin of the Milky Way, but this turned out to be a mistake. And yet we still found the twin in the constellation Ophiuchus. Astronomers have discovered a spiral galaxy with a double disk, which was previously considered a unique feature of the Milky Way. Today it is believed that the thick disk of the Milky Way appeared about 8.5 billion years ago as a result of its collision and merger with another large galaxy. This led to the fact that most of the ancient stars were ejected from the disk of our galaxy, forming a discharged, approximately 1,000 light-years thick, surrounding a thin disk. Now it turns out that most likely the disk of the Milky Way arose in a different way. So astronomers paid attention to the galaxy UGC 10738, which is located in the constellation Ophiuchus at a distance of 320 million light-years from our galaxy. After receiving the photograph, it turned out that its disk also has two different parts that are very similar to similar structures in the Milky Way. However, astronomers saw no signs that this galaxy had collided with another object in the past. Experts have come to the conclusion that the double disk structure appears itself during the evolutionary development of spiral galaxies, so the Milky Way can be considered an ordinary and not a unique galaxy. And yet we are in it. People perhaps in that distant galaxy are thinking the same way. As you know, the Andromeda Galaxy, our Milky Way and other galaxies are surrounded by a large shell, the so-called galactic halo, consisting of gas, dust, and scattered stars. Researchers using the Hubble telescope have mapped the vast shell of gas surrounding the Andromeda Galaxy, and they were surprised to find that this thin, almost invisible halo of diffuse plasma extends 1.3 million light-years from the galaxy, about halfway to our Milky Way and 2 million light-years in other directions. This means that Andromeda's halo is already in contact with the halo of our galaxy. They also discovered that Golo has a layered structure with two main layers of gas nested and separated. Understanding the vast gas halos surrounding the galaxy is extremely important. This reservoir of gas contains the fuel for future star formation in the galaxy, as well as the remnants of the results of our events. Like a supernova, it is full of clues about the past and future evolution of the galaxy. It turns out that the inner shell is about 500,000 light-years thicker, much more complex and dynamic, while the outer shell is smoother and hotter. This difference is likely the result of supernova activity in the galactic disk affecting the inner halo more directly. A sign of this activity is the team's discovery of large quantities of heavy elements in Andromeda's gas halo. Heavier elements are formed in the depths of stars and then ejected into space, sometimes very violently when a star dies. The halo is then contaminated with this material from stellar explosions. As part of the AHA program, the study studied the light of quasars, the very distant shiny nuclei of active galaxies with black holes located far beyond Andromeda. Quasars are among the brightest cosmic objects in the universe, representing the nuclei of galaxies located far beyond Andromeda. The quasars scattered behind the halo seem to illuminate it, which makes it possible to study these areas in detail. Looking through the halo at the light of the quasars, we saw how light is absorbed by Andromeda's halo, and how this absorption varies in different regions. Andromeda's huge halo is very thin and does not emit easily detectable radiation. Therefore, tracking the absorption of light from a background source is the best way to study this material. The researchers used the unique capability of Hubble's spectrograph to study ultraviolet light from quasars because ultraviolet light is absorbed by the Earth's atmosphere. which makes observation impossible with ground-based observations. The team used this Hubble scientific instrument to study the greater distance from the Earth to the Sun for comparison. If the Sun were the size of a coin with a diameter of 2.5 centimeters, then the nearest coin star would be at a distance of 720 kilometers. So the stars themselves most often do not collide during a galaxy merger, and yet the merger will still affect stars like in the Andromeda Galaxy and in our Milky Way. Andromeda contains about 1 trillion stars. The Milky Way contains about 300 billion stars. From both galaxies will be thrown into new orbits around the newly united galactic center. Probably our Sun will be thrown into the new region of our new galaxy, and the sky will become different. Nevertheless, the Earth and the solar system are not in danger of destruction. Moreover, as you know, before the merger, humanity has completely different plans. No less than in about 3 billion years, the Milky Way and Andromeda will get so close that from the Earth the Andromeda Nebula and its brightest will be clearly visible with the naked eye stars, and in size and brightness it will approach Luna. But the question arises, what will happen to the galaxies if you look at them from the side during a collision? Large galaxies absorb smaller ones entirely, and this, practically, does not affect their structure. But when galaxies are similar in size like the Milky Way and the Andromeda, collision leads to the destruction of their structure. A number of stars will certainly be thrown out of the galaxies. Others will be swallowed up by merging supernovae with black holes. The beautiful spiral structure of both galaxies will be disrupted, and a new giant elliptical galaxy will form on them together. Such interaction can provoke a small surge in star formation. The collision of galaxies forms vast hydrogen clouds that can cause a number of gravitational collapses. In addition, such mergers cause premature aging of galaxies, since most of the gas turns into stars after the burst of stars in the galaxies the fuel runs out. The youngest and burning stars explode as supernovae, and all that remains are old cold red stars living for a very long time. Well, a collision of galaxies is an event on a truly grandiose scale. Nothing in the universe can compare with this phenomenon in magnitude, except perhaps the Big Bang. After the advent of the Hubble Space Telescope, launched into orbit in 1990, it became possible to personally observe the collisions of distant galaxies. Let's see what the James Webb Telescope is capable of. Such cataclysms happen to any of them as soon as they come close carelessly. In some cases, galaxies only touch each other in passing. In others, direct impacts follow like a head-on collision of cars, decisively changing the appearance of both objects forever. I wonder what our galaxy will look like in billions of years, but it will be completely different, and in the distant and mysterious valleys of space where the stars twinkle against the background of the dark mantle of the night hides. A huge galaxy that attracts the eyes of astronomy lovers, dreamers, and writers. This galaxy is named Andromeda, and today we will make a grand journey to it, to the heart, to the very center of the galaxy. An alluring adventure with bewitching bright colors, and the promise of new ones begins right here. The Andromeda Galaxy, or M31, is our closest stellar neighbor on a clear night. It can be seen in the sky with the naked eye. It is located at a distance of about 2 million light-years from the Earth, and its diameter is approximately 200,000 light-years. And, although it seems incredibly far away, in fact it is not at all like that. Unlike other TEAs, it has a bright hollow or a giant luminous cloud consisting of stars, as well as very rarefied ionized gas. If this halo could be seen without magnifying lenses in the visible spectrum, it would be 3 times larger than the constellation Ursa Major. The area of the huge hollow around the Andromeda Galaxy is huge, and is located approximately halfway to the disk of the Milky Way, and in some places even stumbles upon our galaxy's own halo. Yes, in fact, the galaxies are incredibly close to each other. We begin our journey by flying past the spherical component of M31. We are getting closer and closer. We are approaching directly to the disk of the galaxy with noticeable spiral arms. At least 35,000 variable stars of various types have been discovered in M31. First of all, these are bright Cepheid stars with a certain relationship between period and luminosity, from which the distance to them can be determined. Most Cepheids have a period from N to 125 days. Among other known types of variables, bright blue variables, Lyra-type variables, long-period variables, as well as variables of the AP type of the northern corona. In the Andromeda Galaxy flare, on average about 50 new stars per year, and in total at least 800 such objects have been registered here, while the ratio of the purity of outbursts of new stars to the luminosity of the galaxy is quite low compared to other galaxies. This may be due to the low rate of star formation in M31. About 2,000 sources of X-ray radiation are also known. X-ray binaries and supernova remnants, as well as evil white dwarfs with high temperatures. Some sources are observed in the globular galaxy. The brightness of the M31 cluster in the X-ray range is higher than the globular clusters of the Milky Way. Another difference between the sources in the Andromeda Galaxy and the sources in our galaxy are concentrated in the center. Currently in M31, only one exoplanet candidate has been discovered, temporary name PA99N2, but there is no doubt that in the Andromeda Galaxy there are millions or even billions of planets orbiting its many stars filled with a lifeless atmosphere or, possibly, other flora, fauna, organisms and creatures. The search for planets outside the solar system is extremely difficult because planets do not emit light. All exoplanets whose existence has been confirmed are within our galaxy, but as optical technologies and data processing methods develop, we will be able to find more planets every year located further in the universe. Meanwhile, we have approached the central part of Andromeda called the bulge or sphere distant, a condensation of stars in the center of the galaxy, as well as the brightest part of the spherical subsystem of the galaxy. In this image taken by an orbiting telescope, the crowded, like a space bus and very bright central region of the Andromeda Galaxy, a bright point to the right of the center is visible. This is a group of stars located around the black hole of the galaxy. Blue dots scattered throughout the image are ultra-blue stars that have prematurely shed their outer layers of material, revealing extremely hot cores. It is likely that in this central part of Andromeda, there are many other similarly hot stars in earlier stages of their lives, but they are too dim for us to detect them directly. Now, on our journey through the galaxy, we have come closer to its very heart. In this image, the clearest image of the galactic core ever taken in visible light, a supermassive black hole with a mass of more than 100 million solar masses is located at the center of the event horizon of the closest region around the black hole. Where else might the light be coming through? Too small to be seen. But near the center of the compact cluster of blue stars at the center of the image, a compact cluster of blue stars surrounded by a larger binary nucleus. The binary core of M31 is an elliptical ring of old, reddish stars orbiting a black hole, but it is more distant than blue stars when the stars are in the center of the image. At the farthest point of their orbit, they move more slowly and create the illusion of a second core. The blue stars surrounding the black hole are no more than 200 million years old, so they must have formed near the black hole in a sudden burst of star formation. Massive blue stars are so short-lived that they would not have time to migrate to the black hole if, of course, they formed elsewhere. Astronomers are trying to understand how young stars formed so deep inside a black hole's gravitational grip, and how they even survived such an extreme environment. As we delve deeper into the mystery of the black hole in M31, its enormous size, power, and complexity are revealed, giving us amazing insight into its fantastic role in shaping the cosmic landscape. Its irresistible gravitational force not only attracts gas and dust to the stars, but also causes them to orbit and spiral towards the event horizon of the invisible edge. Nothing, not even light, can escape its capture as technology advances and our ability to study the universe expands. The supermassive black hole at the center of the Andromeda Galaxy will become an even more exciting object of scientific exploration as we continue to unravel its mysteries. This cosmic miracle will undoubtedly become a beacon of knowledge for many generations of astronomers and enthusiasts, but our goal is to immerse it, perhaps by sending a probe there. An instant and the device disappears from the radar. Good try. It seems our journey has come to an end today. We crossed the vastness of space in the Andromeda Galaxy, encountering wonders that are difficult to imagine, supernovae emitting unearthly light, a nebulous, juicy creature coming from its gas nursery, and of course, a huge supermassive star. The black hole plays a major role in the symphony of cosmic evolution. The journey to the center of Andromeda was just the beginning, and we are ready to chart a new course for the next great adventure and new musical discoveries. The Andromeda Nebula has been known to people since ancient times. The Chaldean priests and learned astronomers of the ancient world were the first to notice this. The ancient Greeks also knew about it. After all, it was thanks to them that the galaxy got its name, because Andromeda, the heroine of the ancient Greek world, was the daughter of the Ethiopian king Khafi. As punishment for boasting Khafi, the god Maria Poseidon ordered the king to sacrifice a sea monster to the tap. Otherwise, the kingdom would have suffered a natural disaster. But Princess Andromeda was saved. The brave hero Perseus, who on his winged horse Pegasus was able to defeat the evil Kraken, as a result of which the names of the heroes were named in these myths. Perseus and Andromeda were called bright stars in the night sky. Only later it turned out that Andromeda is just a star in the whole galaxy, and the Perseus cluster is even something more, a real cluster of galaxies. Gradually the myths became public. The past and technology are replacing bedtime stories, and already at the end of the 10th century, English astronomer Isaac Robertson was able to take a beautiful photograph of the Andromeda Galaxy. However, he mistakenly considered it to be part of our Milky Way galaxy. The understanding that the Andromeda system is a whole separate galaxy with many of its own stars came already at the beginning of the 20th century. American astronomer Heber Kern, who observed Andromeda, noticed that the stars of the Andromeda Nebula are 10 magnitudes dimmer than in other places. According to him, they were separated from us by 500,000 light-years. He was the first to put forward the hypothesis of spiral nebulae, or as it was also called, the island universe hypothesis. According to this hypothesis, spiral nebulae are separate full-fledged galaxies. Experimental confirmation of Curtis's ideas came a few years later thanks to another astronomer, Edwin Hubble, with his famous Ostomy telescope. It was Edwin Hubble who calculated the exact distance to the Andromeda system at 2.5 million light-years, and it was he who finally proved that our universe consists of many galaxies. Only Ani is the Milky Way, as previously thought, and Andromeda is just one of countless galaxies around the Andromeda Galaxy, or M31, which means the 31st number in the well. The famous catalogue of Messier, the most famous of the stars of Rome and everyone's attention, is characteristic of the next largest and largest space object M31. It also stands out for its scientific value, since there are not many galaxies in which millions of individual stars can be seen, even if you look at them through the most modern powerful telescopes. And even fewer are those that are approaching us at a speed of about 11 m-music. Once in the past, an image of our home of the Milky Way was drawn from Andromeda. M31 was perceived as a mirror of the Milky Way, but with the development of astronomy this myth was dispelled. It turned out that the Milky Way and Andromeda belong to different subclasses of spiral galaxies. Yes, and the pattern of their arms is completely different, but they have a lot in common. Dwarf satellite galaxies have a similar internal structure. The Andromeda Galaxy appears as a spiral of arm lines evenly spaced around a spherical bulge. The central bright part of the galaxy consists mainly of bright old stars moving in long, elongated orbits. Milky Puja is today perceived as the spiral galaxy SBBC barred galaxy. The difference between our galaxy and M31 is precisely the band. This part extends from the edges of the convexity and connects it to the shoulders. However, there is speculation that Andromeda may also have a bar. Evidence was provided by the massive infrared space exploration program. What does it mean to study the entire sky in the 2-micron range of light? Showed that the bulge of the Andromeda Galaxy, hidden gas and dust, except for infrared radiation, has a square shape, which most likely suggests the presence of this very jumper, but even without taking into account the jumper. The Andromeda Nebula is, of course, different from the Milky Way. Its spiral arms are further apart than the arms of our galaxy. And although their line rarely has a perfectly even shape in M31, some arms are highly distorted. These are the so-called holes from smaller galaxies that flew through the disk of Andromeda. Such events are not uncommon for our neighbor 10 billion years ago. It was formed from several ruptures, and during its existence it has already absorbed at least 3 of its satellites. Continuing to grow in size, the core of the Andromeda Galaxy, like the cores of many other galaxies in the universe, has candidates within it that have the potential to become supermassive black holes. As a result of calculations, the mass of such an object can exceed a mass equal to 140 million masses of our Sun. In addition, the Hubble telescope discovered a mysterious disk containing young blue stars. Surrounding supermassive black holes, they orbit the relativistic object in the same way that planetary bodies do around their stars. Astronomers have been a little puzzled by how such a disk managed to form so close to such a huge object. According to calculations, huge tidal forces above massive black holes' gas and dust clouds must be limited as the formation of new stars condenses. But further observations will most likely give us a clue to solving this mystery. But we continue to approach the Andromeda Galaxy. According to rough estimates, the Milky Way may contain about 300 billion stars. But this is nothing compared to Andromeda, which may contain about 1 trillion stars thanks to the Hubble Space Telescope. Researchers have learned that among this trillion there is a very large and rare population of hot and bright stars. Hot young stars usually appear blue. However, the blue stars found in the Andromeda Galaxy appear quite aged, more like the Sun. Stars that have burned out their inner layers and exposed hot blue cores, scattered throughout the center of the galaxy and are brightest in ultraviolet light range. In addition, there are other interesting objects located in the core of M31. such as the discovery of a double star cluster in the center of the Andromeda Galaxy. This discovery turned out to be very valuable for the astronomical community, since the merger of two clusters into one could occur in a fairly short time, approximately 100,000 years. Based on calculations, astronomers determined that the merger should have occurred millions of years ago, but for some strange and as yet unclear reasons this did not happen. According to one hypothesis, in the middle of M31 there may not be a double cluster at all, but something like a ring consisting of old red stars. The ring may look like two clusters. Since during observations we see only stars exclusively on the opposite side from it, the ring with the disk faces one side towards our galaxy, from which we can conclude that there is a certain interdependence between them when studying the center of the Andromeda Galaxy using the Newton HMM telescope by a group of astronomers. Also, 63 discrete sources of no radiation were discovered. Most of them, and these 46 objects, were identified as double X-ray stars, and the remaining objects were presented as neutron stars or black hole candidates from binary systems. Currently, about 460 globular in the Andromeda Galaxy clusters have been recorded, the most massive of which has a small 2, or GO, has a luminosity greater than any cluster in the local group. It is even brighter than the brightest cluster in the Milky Way. It is located at a distance of about 130,000 light-years from the center of the M31 galaxy and consists mainly of about 300,000 old stars, as evidenced by its structure, as well as the belonging of stars to different populations. That this is probably the core of the ancient dwarf Galaxy, once absorbed by Andromeda. According to research, at the center of this cluster there is a candidate black hole with a mass of 20,000 suns, and a little later, astronomers discovered in hollow M31 a completely new type of star clusters containing hundreds of thousands of bright stars with almost the same number as globular clusters, but different from globular clusters is that their diameter is much greater than several hundred light-years, and also that they are less massive and the distance between the stars in them is also much greater. They may represent a transitional class of systems between globular clusters and dwarf spheroids and distant galaxies for which no analogs have been found in the Milky Way. But there is something else interesting in Andromeda. There is a star Pa-9, around which the first exoplanet to be discovered outside the Milky Way paths. But at this point the planet's timing is still considered unconfirmed. Other powerful telescopes need to be checked. However, you will agree with the scale of the Andromeda system, the presence of many stars and even more planets in it. It is quite possible, at least according to the logic of probability theory, that among this many planets there are planets suitable for life or already life on this. Amazing facts from this: the galaxies don't end at M31 yet. Several of the satellites are dwarf galaxies containing only a few billion stars each. Even amateur astrophotography of this galaxy is clearly visible. Two of them are M32 and M110. M32 itself was most likely a spiral galaxy until recently, but its powerful neighbor suppressed the formation of spiral arms with its tidal forces. These same tidal forces stimulate the exchange of stars from M110. In hundreds of thousands of years, we will be able to see everything much better, since the collision of the Andromeda Galaxy and the Milky Way will inevitably occur in about 4 billion years. We'll get pretty old. Of course, the collision of galaxies and the understanding of astronomers is not at all head-on rams and not at all short-term catastrophes. The distance between the stars is so great that when two galaxies collide, a peculiar process of diffusion occurs when the stars of one of them float freely between the stellar group, and this continues for hundreds of millions of years And since at the same time, the time when the galaxies exert an active gravitational influence on each other, and as a result of these influences, they change their orbits and seem to mix like sugar and salt with water. Sometimes this leads to galaxies either being destroyed or merging with each other. The likelihood of any direct impact on the Sun and planets is small. But on the other hand, it is possible that during the collision the solar system will be completely thrown out by gravitational forces from the new galaxy and become a wandering intergalactic object. This will not cause negative consequences for our system, except for the gradual disappearance of the beautiful starry sky from intergalactic radiation. The magnetosphere of the Sun may be able to protect us. The probability of being ejected from the disk of the Milky Way at the first stage of the collision is estimated at 12%, and the probability of being captured by Andromeda is 3%. By that time, the evolution of the Sun and its subsequent transformation into a red giant will have much greater significance for life on Earth in 5 to 6 billion years. In any case, keep your suitcase handy. Well, we tried to collect all the most interesting facts about our hot neighbor. If you want in the new sky, then the best time for observations will be autumn and winter. In a dark suburban sky, it will be visible to the naked eye. And due to the finite speed of light, we see this object as it was 2.5 million years ago. Say on Earth 2 million years ago, there were no representatives of the modern human species. Unfortunately, according to the theory of relativity, there is no way to know what the moment looks like, because what we see for us is the present moment. Our universe is huge and there are many large objects. These are planets, giants, stars in comparison with which our Sun is just foam clusters of galaxies and superclusters of wall galaxies. And this is a series that can be continued in the direction of increasing size and mass. And at each point in this series, you can find its famous record holder, discovered today. In this video, we will introduce you to the largest galaxies in the observable universe. Until relatively recently, our Milky Way galaxy was considered the largest and even the only one in the universe, and people had no idea about the existence of others. They changed the idea of discovering the universe, which confirmed the existence of many other galaxies beyond ours. The discovery of Hubble by astronomer Edwin Hubble revolutionized astronomers' traditional understanding of galaxies and the universe at the time, and marked the beginning of a vast new scientific field beyond galactic astronomy. Since then, when new telescopes were invented and science did not stand still, the record holders for the title of the largest galaxy constantly replaced each other before starting to get acquainted with the real record holders. Let's remember the parameters of our Milky Way galaxy, this spiral galaxy. With a diameter of just over 100,000 light-years, there are from 100 to 400 billion stars, and it would seem that, compared to other spiral galaxies, the Milky Way has a fairly large mass and high luminosity, but this is not the case, and our galaxy is far from the largest in the vast expanse universe. Well then, let's start with the fifth place in our galactic parade. This is 3C 348, or Hercules, in the yellowish galaxy with a diameter of half a mile of light-years, the distance of which is about 2 billion light-years from Hercules, and is one of the brightest extragalactic paths. There is a black hole in Hercules that is 1,000 times more massive than the black hole at the center of our galaxy. The next galaxy, which has long been considered the largest in the observable universe, is IC 1101, and the fourth, living in the large galaxy cluster Able 2029, located at the very edge of the Virgo constellation at a distance of just over 1 billion light-years from Earth. The galaxy has a diameter of about 6 million light-years. Compared to the Milky Way, it is 60 times larger and 2,000 times more massive. If IC 1101 were in the Milky Way's place, It would engulf a large cloud and several Galen clouds, the Andromeda Nebula, and even the Triangulum Galaxy. But why such a huge size? The thing is that IC 1101 is a real predator. The galaxy is incredibly thick and was formed by many collisions with much smaller objects such as the Andromeda Galaxy or Bleach. The path that it constantly absorbs, on its way there are other galaxies that are inferior to it in size and mass, because such an object simply cannot resist the force of its gravitational attraction, but IC 1101 is, so to speak, a mitigating circumstance. It consists mainly of old stars that have left the main sequence, despite their impressive size in it. The rate of birth of new stars is much lower than, for example, in our Milky Way. Therefore, in order to survive, it absorbs other galaxies, thereby enriching itself with new objects in front of you. UJ 9555 is a huge galaxy that ranks third. The galaxy is located in the direction of the Giraffe constellation at a distance of 820 million light-years. From Earth, this huge star island reaches a diameter of just over 8 million light-years. Currently, the mass of this radio galaxy is quite difficult to estimate. However, experts believe that this is at least 70 trillion masses, for example. And most of the huge galaxies UJ 9555 reached such sizes and acquired such a solid mass due to the fact that they mercilessly absorbed neighboring galaxies, the cluster in front of you. Almost the leader, but still second in our today's intergalactic battle 3C. Located 236 and 15 million light-years away, the Class II Riley radio galaxy is one of the largest known radio galaxies and is located in the direction of the constellation Leo Minor. The galaxy has a double radio bridge, consisting of a giant relic source and an internal, more compact radio, and a recent episode of star formation near the core may be associated with an event that led to the reignition of radioactivity. And, finally, 2. We have a winner for today, the galaxy Alcyone, in a new study. It turned out that its length is already more than 16 million light-years. It is located at a distance of 3 billion light-years from Earth. The so-called shells inherent in all large galaxies, including our Milky Way, helped researchers get to the cosmic supergiant. The presence of similar petals at Alcyone was discovered using a low-frequency tractor consisting of 20,000 radio antennas installed on 2 platforms in different European countries. The discovered galaxy turned out to be a real supergiant, which has never been seen in history. Observation history. A supermassive black hole has been discovered in the center of Alcyone, which slows down the formation of new stars and thus greatly affects the life cycle of the galaxy as a whole. Sometimes this leads to violent scenes. For example, a black hole absorbs material from a giant disk. 2 jets can be formed around itself, which eject fueling new stars from the galaxy at close to the speed of light. These jets travel vast distances and then become giant radio, transparent petals in the process. Stardust heats up so much that it dissolves in plasma and begins to glow in the radio range. The galaxy has other impressive characteristics that the researchers were able to measure thanks to the SDSS survey. For example, the supermassive black hole at the center of Alcyone is 400 million times more massive than our Sun, and the weight of the entire galaxy is estimated to be 240 billion times our mass. Speaking about the reasons that led to the growth of the Alcyone galaxy to such a huge size, researchers are still perplexed. At first, it turned out that the cause was an incredibly huge black hole in the center of the galaxy, a huge stellar population and, accordingly, a large amount of dust or extremely powerful jets. To our surprise, it turned out that Alcyone in all these parameters does not stand out from a number of smaller radio galaxies, and therefore it is planned to study the surroundings of Alcyone in more detail in order to assess their possible influence on its growth. Since the researcher notes that despite the gigantic size of the discovered new space object, it is still in the stage of active growth and the baby continues to grow far in the darkness of space. But what Alcyone will appear before the astronomers of the universe can only be assumed. Future generations. As you may have noticed, most radio galaxies are gigantic in size. But why not all of them are so huge remains a mystery. Such giants are believed to be the oldest existing radio galaxies. It took quite a long time, perhaps several 100 million years, before their radios grew to enormous sizes. If this is so, then there should be many more giant radio galaxies than are known today, and the discovery of such giants and their study helped determine the evolution of time in principle, because we are talking about a powerful galactic structure that arose from a once completely unremarkable galaxy. A galactic center is also needed. Black holes play this role. Supermassive black holes, with masses exceeding 1 million solar masses, are located at the centers of large galaxies and play a huge role in its evolution, holding the rest of the stellar mass in the form of a nascent galaxy and forming a galactic form with it. Powerful gravity. For example, in young galaxies, new stars light up very actively over time. In reality, this activity decreases. The star formation process depends on the activity of the black hole at the center of the galaxy. After analyzing the spectra of nearby galaxies, their age and the rate of formation of new stars were established by comparing these data with MAMI, located in the centers of galaxies. Differences have been discovered that cannot be explained by other parameters of the galaxies, their sizes, shapes, or rotational features. As a result, galaxies with the same total mass but different black hole masses evolved differently. In those with more massive black holes, new stars were born more actively and the star formation process stopped faster. In this case, black holes attract dust, gas, and stars from the immediate vicinity. For matter located near the black hole, but not yet fallen into it, an accretion disk is formed in it. Matter swirls around the black hole like a funnel and heats up due to friction. So it begins to glow brightly across the entire spectrum when the matter of the promodisk interacts with the black hole. Radiation pressure and the influence of the magnetic field throw some of the matter away from the black hole. Something similar was observed in the galaxy ICE F231228, located approximately 600 million light-years away. Here we see the merger of two galaxies, and at the same time the supermassive black holes of the merging galaxies are actively absorbing the matter surrounding them. However, they throw some of it away. Therefore, huge amounts of gas and dust are ejected from the central regions of the galaxy to the periphery. Astronomers were able to establish that inside these flows there are many young stars no older than tens of millions of years, and an analysis of their speed showed that young stars move from the center of the galaxy at the same speed as the gas surrounding them, which means that they were formed from the same flows of matter. Thus, for the first time, it was possible to show that supermassive holes in the center actively contribute to the formation of new stars. Previously, hypotheses of this kind have already been put forward, but they could not be verified by observations. It is also interesting that from the moment of its birth, the stellar nebula, which remains from a superstar to a quasar, the galaxy changes its shape depending on the processes occurring around and in the galaxy itself. Undoubtedly, this is facilitated primarily by the activity of Noah's hole and the shape of the galaxies. In addition, long-term observations have shown that the farther the stellar material in a galaxy is from the galactic center, the slower the black hole rotates, especially in elliptical galaxies. And in lenticular galaxies, the speed of rotation of the galactic center gains strength. The black hole begins to increase the speed of its rotation with the steel of the surrounding matter. Noah's hole in spiral galaxies. The black hole has a higher rotation rate than in elliptic or lenticular galaxies, and the black hole's rotation axis is stabilized along the galactic arms. In barred spiral galaxies, the rotation speed of the black hole is greater than in ordinary spirals. The rotation axis of the galactic center is stable in the rod axis and is the limit for the galactic shape. In the quasar, the rotation speed of the black hole reaches its maximum. The surrounding matter rotates along the axis of the galactic center, from which we can draw the logical conclusion that the gravitational forces of the black hole hold the enormous mass of the entire galaxy. But it looks like the black hole isn't acting alone. He has a companion. This satellite is dark matter. Back in 1930, astrophysicist Fritz Zwicky wondered why galaxies do not disintegrate and gave the answer that the self-gravitational force of galaxies is small enough for their formation and, naturally, there is a greater force than the attraction of the galactic core. He later proposed another conclusion based on the first one, and was later confirmed by many researchers that dark matter could exist based on velocities in galaxies and galaxy clusters. Since 2000, when modeling virtual galaxies, it became clear that dark matter really exists and takes part in the formation of galaxies. It acquires them in the form of a frame or web, which does not allow the galaxy as a whole to dissipate in a funnel of water. Contributes to the formation of the shape of the galaxy by a black hole with its unexplored properties and the power of dark matter. From all of the above, we can conclude that galaxies cannot decay on their own. However, they may weaken or, in other words, show little activity, at which point the galaxy will gradually be pulled towards the larger galaxy. This happens often in the universe. This once happened to our galaxy about 9 billion years ago during that period. An unknown dwarf galaxy has been attracted to our Milky Way galaxy. As a result, the dwarf galaxy could not survive this collision and disintegrated, and its stars move around us in very elongated orbits. At this point, the collision played a crucial role in the early history of the Milky Way and changed the structure of our galaxy, playing a significant role in the formation of both the inner bulge and the outer gala. Note: the Milky Way is currently undergoing its next collision with the Andromeda Galaxy, which is expected to occur in about 4 billion years. The manifestation of this collision will occur extremely slowly and may not be visible at all from the ground with the naked eye. The likelihood of any direct impact on the Sun and planets is very small, but on the other hand, it is possible that during a collision the solar system will be completely thrown out of the new galaxy by gravitational forces and become a wandering intergalactic object. This will not cause negative consequences for our system, unless of course we count the gradual disappearance of the beautiful starry sky, but who knows whether anyone alive on planet Earth will observe this. The disappearance of music is an equally important factor in the fate of the galaxy: its mass. The Andromeda Galaxy is ahead of ours in all three respects. However, the degree of its superiority varies. The most noticeable and undeniable characteristic is the size of the galaxy's disk in M31, which extends 110,000 light-years from the center. This is approximately several times larger than the Milky Way, and Andromeda is wanted many times larger. It will remain the largest in the local group of galaxies. Another factor is the number of stars in the Andromeda Galaxy, which is at a distance and clearly visible, They are easier to count than in the Milky Way ways. The estimated number reaches 1 trillion stars. And the number of stars in the Milky Way today is estimated at 400 billion, since Andromeda's mass spans 500 billion solar masses. However, here too the Milky Way is not inferior to its neighbor. Its mass ranges from 0.8 to 1.5 trillion solar masses. There is already interesting information regarding the center of the galaxy in the core of M31. Like many other galaxies, including the Milky Way, there is a supermassive black hole candidate estimated to have a mass of more than 140 million solar masses in 2005. The Hubble Space Telescope has discovered a mysterious disk of young blue stars surrounding a supermassive black hole. As they orbit the object in the same way that planets orbit the Sun, astronomers were puzzled by how such a donut-shaped disk could form so close to the array with which the tidal wave was detected. The forces of a supermassive black hole should prevent the formation of gas and dust stars. Further observations may provide clues. In addition to the supermassive black hole and the disk of blue stars, there are other objects at the core of the galaxy. A double star cluster was discovered in the center of M31, which turned out to be a surprise for astronomers. The purchases will merge into one in a fairly short period of time, about 100,000 years. According to calculations, the merger should have occurred many millions of years ago, but this has not happened so far. There was also an assumption that in the center of the galaxy there is not a double cluster, but a ring of old red stars. This ring may look like two clusters, since we see stars only on opposite sides. So this ring should be located at a distance of 5 light-years from the supermassive black hole and surround a disk of young blue stars. The ring and disk are turned towards us on the same side, which may indicate their interdependence. Since the largest representative of the local group of galaxies, Andromeda, somehow interacts with other galaxies, good or not, but our Milky Way will merge with our galaxy into one in 3 to 4 million years. Although it is very difficult to predict the movement of such huge objects, recent research suggests that a collision is inevitable. And although in 3 billion years we will be a little older, it is still interesting to know how this will happen. Will happen when the galaxies move away to a sufficient distance. Their cores will become huge. Soon during this duet the disks will fly apart by the force of gravitational interactions. They will scatter in different directions like splashes of water. The cores will rotate faster and faster until they merge into a new massive center, and the sleeves will be erased, so a new galaxy will appear, and it is Tweed and therefore not the Milky Way and Andromeda what awaits our system, the Sun and planets are most likely ours, and most systems should remain unharmed, because the chances of a collision between the stars of two galaxies are very small. Let's look at an example. If the Sun is already the size of a table tennis ball, then the diameter of the Milky Way will be 30 million kilometers. And even if you combine the stars of both galaxies, the distance between each star and the ball will be more than 3 kilometers. Are the chances high that the balls will collide, given the fact that real stars, like real galactic nuclei, will repel upon first contact? Don't fight like eggs in a public cafeteria. Of course, such a clash is unlikely. But what's interesting is that the probability that ours, when merging with the Chinese, will become some kind of intergalactic traveler is almost 50%. It may well separate from the Milky Way and go into the abyss of the universe. The planet will not suffer and will not change its orbit, but for the Earth at this time, the greatest danger will be the Sun itself, because after so many years it will be approaching the red giant stage. And this, as we know, is in any case the stage of dying. As the Andromeda Galaxy approaches, new details emerge. We begin to see everything clearly, and our assumptions become less and less like myths, and maybe we will find another life there. Or maybe we have already found it. What do you think about it? Be sure to share your thoughts, and let's watch our space journey. From the galaxy at this moment in time, the closest to the Milky Way is the dwarf galaxy in the constellation Canis Major. It is located just 25,000 light-years from the solar system. It is believed to contain 1 billion stars, many of which have already entered the red giant phase. It had the shape of an ellipse. In addition, a whole string of stars sparkles behind it. This complex ring-shaped shape is called a unicorn ring, a filamentous ring-shaped chain of stars wrapped 3 times around the Milky Way, presumably a moving group of stars separated by the forces of the Canis Major dwarf galaxy as it continues to be consumed. Our galaxy, among other members of the local group with its mass and 2 dwarf satellite galaxies of the Milky Way, the Large and Small Magellanic Clouds, are large clouds of gas and stars that can be detected without the use of technology. However, they can only be seen in the southern hemisphere. They are located at a distance of 160 and 200 light-years from us. But despite the short distance, their features are the howl of the industrial era, but they still continue to hide the secrets of the large cloud Magellanic, which is located in the constellation of the Goldfish. Because of this, it is in 3rd place. Roughly, the small Magellanic Cloud lives in the constellation Tucana and ranks roughly 5th after name. The larger one is larger in diameter than the smaller one. Its radius is twice that of 14 light-years, which also makes it the 4th largest galaxy in the local group. It is possible that these galaxies may be passing clouds that once broke away from Andromeda. The fact that they are in contact with our galaxy is evidenced by the changed structure and flows of neutral hydrogen. Their gravity also affected the Milky Way, distorting the outer part of the disk. These are complex cosmic relationships. In fact, we are surrounded by dozens of different dwarf galaxies. But they are all, to one degree or another, similar to each other. For example, the dwarf galaxy in Draco, the dwarf galaxy in the constellation Sculptor, the dwarf galaxy in Carina, the dwarf galaxy in the Bernard Phoenix galaxy, and dozens of other dwarf worlds simply do not exist. There is no time to consider them all, and therefore we move on to objects further and larger, and the 3rd largest and most massive galaxy in the local group, as well as the closest spiral galaxy, will be the first to pick up this galactic baton. The Milky Way, which has no bar at all. We are talking about M33, or the Triangulum Galaxy in the constellation of the same name, the owner of a massive black hole X7, the mass of which is approximately equal to the mass of the ST Sun. It is believed that the Triangulum Galaxy contains about 40 billion stars, which is significantly less than 2 other large local group galaxies. The Milky Way, for example, contains 400 billion stars, and the Andromeda Galaxy contains a full trillion. The Triangulum Galaxy is currently handing over control of Andromeda. The 2 galaxies have interacted in the past since Andromeda's gravity pulled some stars out of M33. And now this tail extends from one galaxy to another, and some of the stars of the triangle migrated to the Andromeda Galaxy in a friendly company of galaxies extending approximately 3 million light-years in width. In addition to the Milky Way and its satellites, this also includes the Andromeda Galaxy, closest to us, a giant barred spiral galaxy with its satellites dominating the local group, distant from us at a distance of 2s to a mile of light-years. It rightfully occupies a dominant position, since it is 1.5 times more massive than our galaxy, but we will not dwell on it in more detail, since there is already a separate video channel with this world. We continue our path, and the NGC Galaxy 5128 or Centaurus stretches in front of us. And closest to the Milky Way is a lenticular polar ring galaxy in the constellation Centaurus. This is one of the brightest and closest neighboring galaxies in brightness. This galaxy ranks fifth after the Tomb Nebula, Magellanic Clouds, and the Triangular Galaxy. The radio galaxy is the most powerful source of radio emission in the constellation Centaurus. And if we could see in the radio range, the intense radiation of the galaxy would be visible in the form of two huge formations emanating from the center of the galaxy with a diameter of Centaurus and extending over 60,000 light-years. Such star formations are characterized by the absence of arms, and the bright central cluster is highly compressed and somewhat resembles a lens. It consists mainly of old stars, which is why we see them with a reddish tint. The Wolf-Fladd Marmot Irregular Galaxy, discovered in 1909 by Max Wolf. It is located in the constellation Cetus on the edge of the local group, about 3 million light-years away, experiencing tidal interaction with another member of the dwarf elliptical galaxy PJC 2914. Another amazing galaxy PJC 45279, a barred spiral galaxy quite similar to the one we live. However, X-ray observations show the presence of Cipher-Toph sultans in front of the galaxy almost 12 million light-years away, and we are approaching NGC 2976. The spiral galaxy in the constellation Ursa Major is located at a distance of 12 million light-years from Earth. It is of interest to astronomers because of its unusual chaotic internal structure. In fact, the galaxy is divided into a large number of small clusters connected by filaments. In the complex galaxy NGC 5102 in the constellation Centaurus, a supermassive black hole, as we see, is surrounded on almost all sides by giant clouds and bubbles of hot gas. They consist of matter, which is ejected by a black hole and inflated by stellar winds and supernova explosions. We are approaching NGC 45. It is believed that the galaxy was torn apart by the gravitational field of a more massive galaxy behind it, and therefore the core of the galaxy was greatly degraded, as well as tidal forces caused the formation of a long trail of stars. And, finally, the most distant object we will consider. This is Galaxy Quay 5, or IC342. This is an intermediate-type spiral galaxy in the constellation Giraffe, located near the galactic equator, where absorption of radiation by dust makes it difficult to observe the galaxy. For the same reasons, it is difficult to determine the exact distance to the galaxy. Modern estimates occupy an interval of 17 million light-years. Galaxies like these help astronomers better understand the structure and evolution of our own galaxy. Since we cannot look at the Milky Way from the outside, as Milky Way IC342 has a bluish disk of young stars with bright pink star-forming regions. The bright central region of the galaxy is formed mainly by older and red stars. This is one of the largest galaxies in this group, and that's it for our little journey. The review of the most interesting galaxies of the local group has come to an end, and we haven't even aged. The study of these objects is very useful and instructive for elucidating the structure and life history of the most common in the stellar universe.